Hey friends, welcome to follow up. Let's have a look at problem 735, asteroid collision. This problem actually is a typical problem that we can use data structure to help us solve. So in this video, we're going to explain a method based on the use of stack. So here we are given an array asteroids of integers representing asteroids in a row. So for each asteroid, the absolute value represents its size and the sign represents its direction. So positive means right and negative means left. So each asteroid moves at the same speed. So what we want to do is to find out the state of the asteroids after all collisions. So here, if two asteroids meet, so the smaller one will explode. If both are the same size, and both will explode. So two asteroids moving in the same direction will never meet. So here are three examples. So in the first example, the first two actually moving towards right, and the last one moving towards left. So it meets the one with size 10. So the one with size 5, but moving towards left, that is -5, will explode. So we're going to have 5 and 10. So in the second example, so we have 8 and -8. So these two have the same size but different direction. So they both explode. So we get an empty output. So for the last one, so first 2 and -5 meet, so we are going to have -5. Then -5 and 10 meet, we're going to have 10. So that's the output. So the constraints for this problem are the following. First, the length or the number of asteroids at the very beginning is bounded below by 2 and bounded above by 10 to the power 4. And the asteroids can be moving towards left and towards right. So the weight is not 0 always. So here, actually, if you look at the hint, so basically we'll see a row of asteroids stable. What happens when the new asteroid is added to the right? So this is actually a very useful hint, or we even do not need this hint. So now let's look at the analysis. So first we want to observe that, so for two asteroids, only if the left one moves towards right and the right one moves towards left, right? So then they can collide. So this is our getting observation. So in this problem or in this coding part, so we want to point one point which we need to pay attention to. So because after we check collision, we need to check if the one we're currently looking at will explode or not. So now let's look at the coding, and in between we're going to explain the logic, right? So in this, as we mentioned, we're going to use stack. So let's initialize an empty stack, and then we're going to scan the list. I changed the name to be capital A just for convenience of writing. So also let's introduce this length n for convenience of writing them. Then we're going to iterate over this index. So from 0 to n-1. So first I'm going to introduce a flag variable. So originally it's true. So this flag variable basically indicating if the current asteroid, in other words at capital AI, will be collide or will be explode or not, right? Just flagging if AI will explode or not. So initially we are going to write it as true, right? So it means not explode, will not. So here let's see, this one will be flagging if AI will still exist, right? Exist after let's see, collision, right? And this is more precise. And originally it's true, right? This makes sense. And then we are going to check, well, as the stack is not empty, so that we can check this one, the last asteroid. And then we want to check if these two have the opposite sign. In other words, the top element in the stack and the current asteroid have a product which is less than 0. And also we want to make sure s negative 1 is moving towards right, so that is it's greater than 0. So once these conditions hold, so then basically we want to check the collision. So if s negative 1 is greater than absolute value of AI, so this means that you can change this absolute value to be negative AI, because AI is negative. So if this is the case, we know that the AI will explode, right? So then it will not exist after the collision. So we're going to set it to be false, right? And then we just need to break this while block. So otherwise, let's see, if s negative 1 equals absolute value of AI. So in this case, both s negative 1 and AI will explode. So in this case, we need to pop this one, right? So after we pop, we're going to flag that the SI is not exist. So we're going to change this to be false. Then we also need to break, right? So otherwise, so this will be the situation that this guy is larger. So s negative 1 will explode. So we're going to do s pop. If it's still the case, we'll continue doing the pop, right? So this is the while block. So after this while block, so there are several situations. So now just let's check flag variable, right? So actually this s can be empty, or this can be validated, or this cannot be negative first. So we just need to actually overall we just need to check the flag variable. If still true, we're going to do append. Otherwise, continue. So AI. This flag can be true if AI is towards the left and it's very large in size. For example, it's larger than the in size than any of the previous left ones. So with that said, we are ready to return the final state of S. So before we do anything, let's first do a test. Yeah, it passes the first one. Now let's look at the generic case. Yeah, it passes all the generic cases. So here we want to mention that this problem is a typical problem in which we can use data structure to help us solve the problem. So in this coding part, the main point is this flag variable. So we want to use this one to check if after the collision we still need to append this current asteroid or not. So if we notice this point, so basically writing the code will be straightforward. So with that said, basically that's about it for this video.